We are going to evaluate this problem today using logarithmic differentiation. Yes, it looks like a very complicated problem, and you use logarithmic differentiation to break this problem up and make it a little easier to work with. We're going to be using log properties of the power rule, the product rule, and the quotient rule. Product rule is when you have two or more things being multiplied inside of your log function, which allows you to break them up like this using addition. So ln of x plus ln of y. Quotient rule is the opposite, so division. Instead of plus, it'll be subtracted. So ln of x minus ln of y, since y is in the denominator. Power rule allows you to take an exponent inside of your log function and bring it to the front. So instead of it being x cubed in there, it'll be 3 ln x. The first step of logarithmic differentiation is to take the ln, or log, of both sides of your function. Now that we've taken the log of both sides of our function, we can kind of use these rules to break him up. Remember, the square root can be written as an exponent. The exponent of this is going to be 1 over 2. The radical number, or the square root number, always goes in the denominator here. So if it was the cubed root, it'd be 1/3, etc., etc. Now let's break him up. With the power rule, I can bring this exponent all the way to the front, meaning I'll have 1/2 in front times ln of everything else inside. Now let's start breaking up using the other rules. Product rule is going to allow me to take everything in the numerator and add them. And everything in the denominator using quotient rule will be subtracted, meaning I'm going to have ln of x plus ln of x plus 2 minus ln of those other two. So 2x plus 1 minus ln of 3x plus 2. I use brackets here because we need to have this 1/2 be multiplied into every single term, so it needs to just go ahead and stay there. We'll multiply him in at the end if we need to. Now that we have our function in the most simplistic form that we're going to get it, we can go ahead and take the derivative of both sides. That's the derivative of ln y on the left and the derivative of this whole function on the right. On the left side, we're taking the derivative in terms of x of a y function. With that, you'll take the derivative of that y function just like you normally would, as I would for ln x. It'll be 1 over y times the derivative of what's inside that function. The derivative of y is just going to be 1. But since I did the derivative of y in terms of x, you'll be left with the dy over dx, which just means your first derivative of y in terms of x. Now starting on the right side, the constant multiple rule allows me to bring that 1/2 to the front and not worry about it. So it's going to be 1/2 times the derivative of ln x, which is going to be 1 over x, plus the derivative of ln of x plus 2, which is just going to be 1 over x plus 2, times the derivative of x plus 2, which is just going to be 1, minus the derivative of ln of 2x plus 1, so it'll be minus 1 over 2x plus 1, but the derivative of 2x plus 1 is going to be 2. So we're going to multiply this numerator by 2. The last term is minus ln of 3x plus 2. His derivative is going to be minus 1 over 3x plus 2 times the derivative of 3x plus 2. The derivative of 3x plus 2 is 3, so I'm going to go ahead and put that in the numerator. We are almost done with our equation, but we're not quite. We cannot leave this 1 over y on the left side of our equation to have our derivative. We need to have just dy over dx isolated here. That means that we need to multiply by y on both sides of the equation, leaving me with my derivative, what my derivative equals. From the beginning, we knew what y equaled. That was our initial equation to begin with. That means we're going to take this y value and substitute it in place of that y there. And then we will be done with our derivative. So it'll be multiplied by everything under that square root. So that square root and everything underneath it. I do recommend when I do these videos that you pause it and make an attempt on the problem yourself first, and then follow along if you have any trouble. This video is about logarithmic differentiation with Lauren. Have a good day. Follow along for more videos on Calculus 1 and 2.